Hello friends, welcome you all again in the video lecture of B.Sc Electronics class. Myself G. Patil, Department of Electronic Science, ATHM College Nasik. In this video lecture, we shall study the example of implication chart method of state reduction. In this video, we will see how to use implication chart method for state reduction of sequential machine. So let us start. Here one example of sequential state machine is given, or one of the machine is described in the state diagram, and from that diagram you have to prepare the state table of a state machine, and using the implication chart method you have to simplify that state machine. That is, we have to reduce the number of states in that state machine and implement it again. So the problem is that consider the state diagram given in the figure, determine any redundant states that merely state diagram, and in this we have to use implication chart method. If we observe the state diagram of a sequential state machine, the number of states present in the machine are A, B, C, D and E. So total 5 states are there, and in the machine there are two inputs. Here if we observe carefully this part, the directed arrows, these are called the directed arrows, they are shown with the arrows, they shows the state transition from one state to another state under input condition, and what are the outputs are there, they are written after the slash. The value before the slash gives the number of input and type of input, and after the slash it gives the output. If we consider the state A, in that if present state is A and input is 0 0, see this present state is A and if input is 0 0, the next state is state B. So it makes the transition from state A to state B where output is 0. So in this way the state table is to be read. Again, the next state present, if the present state is A and input is 0 1, see this one, the next state is C and output is 0. Okay, and similarly the rest of the cases, well, present state is A and input is 1 0, the next state is the same state while output is 0, and when input is 1 1, it makes the transition from state A to state B and output is 1. Similarly, the state B can be read, state C can be read, state D can be read, and state E can be read. We'll take a state B, present state is B, and if input is 0 0, where is input 0 0? This one, see this line. When the input is 0 0, the next state is E and the output is 0. Then when present state is B and input is 0 1, where is 0 1? This one. The next state is C and output is 0. Then when present state is B and input is 1 0, where is 1 0? This one. The next state is D and output is 1. And when the present state is B and input is 1 1, the next state is again B and the output is 1. So in this way the state table has to be prepared from the state diagram. It is shown in the next slide, so we'll switch to the next slide. See here again this that state diagram is shown here, and that from that diagram the state table is prepared. So same thing are given there, starting with the state A, the number of state they are written in the present state. So since there are 5 state A, B, C and E, so in the present state column there are 5 state A, B, C, D, E, and in the next state, here the next state and output condition, As we described, there are two inputs, say x and y, and we'll assign the value to x and y like 0 0 0 1 1 0 and 1 1, and there is one output at every place, so we'll say that output be a z output. So the next state and output is written in this way: next state is xy and where the output is z, and the next state values having four combination, either 0 0 0 1 1 1 and 1 0, and there is always a z output with every next state condition. So the state table has to be prepared in this way: the first column is present state and the next is the next state and z. So there are two inputs, 0 0 0 1 1 0 and 1 1, and for every input condition there will be the output. So the table has to be prepared this way, and under each state condition, say starting with a, check the values of the input 0 0. Here, when the input 0 0, present state is A, present state is A, and input is 0 0, present state is A. Here it is input 0 0, next state is B, and output is 0. So it is written next state is B and output is 0. Then when present state is A and input is 0 1, present state is A and input is 0 1, the next state is C and output is 0. So next state is C and output is 0. Similarly, when present state is A and input is 1 1, this one present state is A and input is 1 1. What is next state? Next state is B, which is written here, and the output is 1, which is written in the output column. And for last input condition, that is 1 0, present state is A and input is 1 0 1 0. The next state is the same state, that is A, which is written here, and the output is 0. It is okay. So in this way, the state table is to be filled for all rest of the present state values like B, C, D, and E. So you might have understood how to prepare the state table from given state diagram. It is a very simple, even though it appears to be complex, somewhat complex, but it is not so complex. It is very simple. Just you have to follow the step by step method, so that we find it very simple and very interesting to prepare the state table from the state diagram. So uh, the rest of the conditions or the states are to be filled from this state diagram only. In this, the careful observation is required, like a number of states which are shown here. So prepare the number of state and the number of inputs. There are two inputs, so we have assigned the variable x and y for two input, and there is only one output, so we have assigned a variable z. So in this way, the some state assignments are required to be done, and once we understand that, it finds to be very interesting, easy to understand the state machine and state table. Okay, now next, here we have to use implication chart or implication chart method for finding the redundant state or the equivalent state. So in the earlier lecture, we have studied the implication chart method of the state reduction. In that implication chart, it is nothing but grid arrays in this way. Along the row contains all the state except the last one. Here the number of states are A, B, C, D, E. Last state is E, so that last state is not there. And along the vertical column, we take all the states excluding first one, that is A. So B, C, and E, and accordingly prepare these squares. Okay, that is we know very well. So we'll proceed towards the filling of the implication chart. First of all, what we have to do, we have to observe the state table carefully. Is derived from or prepared from the given state machine in the state diagram form. So let us observe it very fast. We take care of the outputs only. Depending on the output, we fill the implication chart. Now, observe the first state or first square AB. Can say AB. This first square represents the AB, or in the table, the first two state AB. First of all, we have to check the output only. We have to check whether the outputs are same or not. As per the definition of equivalent state, the two states are said to be equivalent if their outputs are same and next states are equivalent. So the very first thing, we have to observe the outputs of the states, and if in one of the column the outputs are different, those states cannot be equivalent. That should be very clear. So first two state A and B, observe the output column. Here output 0 0, it is same. 0 0, it is same. 1 1 is same. Here 0 1, these outputs are different. It means A and B cannot be equivalent, and under such condition, in the square we insert cross, or X is placed in the squares where output is equal. So what is to be placed there? X has to be placed there as shown here. Then check the next state AC. Check the output 0 0 0 0 1 1 and 0 1. So these states cannot be equivalent. So cross mark is placed, indicates that two states cannot be equivalent. Then check the next AD, or here we can observe AD. In the AD state, A and D row, observe the output. Here are 0 0 0 0 1 1 and 0 0. So these states can be equivalent. So left it now. Then AE, check the AE output conditions 0 0 0 0 1 1 0 0. So AE can be equivalent. So remain it as it is, don't place the cross mark there. Then the next query is BC. So check the state BC for output 0 0. Here is 0 0 1 1 1 1. So it has to be left uncrossed. Then BD, check the BD 0 0 0 0 1 1 1 0. These are the different. Put is different 1 and 0. So you have to place a cross mark in a B pair. Then P and E, check outputs 0 0 0 0 1 1 1 0. Output is different, so place the cross mark. Okay. Then CD. The cross mark is entered earlier 0 0 0 0 1 1 1 0 is entered readily. Then CE, check the conditions or state CE. Here is 0 0 0 0 1 1 and 1 0. So again I have to place a cross mark there. And okay, now we have to enter the implied states by which the remaining uncrossed states are equivalent. So the first is AD. In a AD, now we have taken care of the outputs. The first step. Now the next is to be entered the implied state pairs by which those squares or those state pairs are equivalent. So here AD, check the states AD. What are the implied state? BC, CD, AB and AB. So the states are BC. BC is already entered. Then DC, here DC, or we can say CD. Then next is AB. So in this way, those implied state pairs are to be entered. Then check for AE. A and E. Check the implied states by which they are equivalent. BC. So enter BC and the next is E. The single state need not to enter. Again the BC same pair and A. So BC and A are the implied state pairs by which A and E state can be equivalent. Then check for the B. B and E. C E. You see this is the same one. BC and DE. So enter those states here. BC. Here BC is checked. For BC, AE, same pair and D. So BC and AE. Okay, that is entered. Sorry. Then check for BE. E that EC is same pair DE. So these are the pairs CD for CD, BE and AC for state ED, and the remaining placed BC. BC is crossed. Sorry, B is crossed. Now take the key 0 0 0 0 1 1 and 1 0. So that pair is crossed. So in this way, application chart has to be built by observing the outputs and next states. So the steps are written here. First of all, place a cross mark or the X mark in the square where outputs are different. Then check for the implied equivalent pair AD. A is equivalent to D. A is equivalent to D if and only if B is equivalent to C, and the rest of the pairs they are written there. A is equivalent to E. A is equivalent to E if and only if B is equivalent to C and A is equivalent to E. Then B is equivalent to C if A is equivalent to E, and the last one D is equivalent to E if C is equivalent to D, B is equivalent to E and A is equivalent to C. What are the implied state pairs are there by which those state squares can be equivalent? Once it is done, the next task is to cross the pair where those states are get crossed their respective squares. So here AB is crossed, C is crossed, BD is crossed, this one CD is crossed and is crossed. So in the remaining square where these crossed state pairs are there, those squares will get crossed. So first is here. This is get crossed. Why it is get crossed? Because it contains BC in its square here depends on A. So then the next applied pair is DC. Check the DC. DC. Where is DC? Or C. It is get crossed. So this is get crossed. Again, where is DC or CD? It is here. So that will also get crossed. Okay. So after crossing those squares, which set squares are remain uncrossed? One is remained uncrossed and this one is remained uncrossed. Those states are said to be the equivalent states. So it is written here. After the evaluation of squares of implied state equivalencies, it gives the following result. A cannot be equivalent to D. A cannot be equivalent to D because A is not equivalent to B. A is not equivalent to B. Why? It is crossed. And D is not equivalent to C. Another implied pair is DC. So this is cannot be equivalent. This state cannot be equivalent. Second, D cannot be equivalent to E because A is not equivalent to C. Say check the AC square. AC square it is crossed, and B is not equivalent to E. Another uh, next Implied square B and E state it is also get crossed, and C not equivalent to D. If one of the pair or one of the state pair is crossed, then also that corresponding square get crossed. So the states which are equivalent are A is equivalent to E. This is uncrossed square. So A and E is equivalent if and only if B is equivalent to C. B is equivalent to C. And E is equivalent to C if A is equivalent to E. So this is the symmetry, property of symmetry of equivalent state, and by this property these state pairs are said to be the equivalent state. So what we understand that after seeing the implication chart, after filling the implication chart, and after evaluating the implication chart, we come to know that the squares which are left uncrossed corresponding states are the equivalent states. So here A is equivalent to E and C. So it is a very simple method by which we can find the equivalent states, and we can reduce the number of states there. So is what the implication chart method. The next thing is reduce those current states in the given state table. So this is the state table at the start of the example or video. Now prepare from the state diagram, and in that what we have to do, wherever state C is there, it is to be replaced by B because B is equivalent to C, and where state E is there, it has to be replaced by state A. So in that table, say state C has to be replaced by B and E has to be replaced by A. So we'll see row by row. Here A, B, C is there replaced by B. Here no C and E. Here E is there. E has to be replaced by A, has to be replaced by B and E. Again, C has to be replaced by B. C has to be replaced by C has to be replaced by B. C has to be replaced by A by B. C is replaced by B. Here is also by E, A. After doing that, come to know that see here A and the last row A, B, B 0 0, B, B 0 0, B 1 1, A and so this first and last row is exactly same. There is no need to have two same rows in the state table. So instead of using these two row, we'll write only one row in the modified state table. Again, see here B and C. These two row are exactly same. A 0 0, B 0, B 1 1, D 1 1. So instead of writing two rows, we'll write only one. So here one of the row get eliminated, here one row is get eliminated, and after doing that, what are the states left? So the state lefts are A, B and D. A, B and D. So after that we can just rename the state like this. It is done in this state table. From the chart it is we know, therefore replace E with B. That is what we have explained, and after doing that we have to rename the state, or we can keep it as it is and we can write prepare the state table. So here A is renamed as S0, B is renamed as S1, and D is renamed as S2, and accordingly the state table is prepared. The next state X, Y, and Z, they are same. See here, first A has to be replaced by S0, B has to be replaced by S1. This output column will not change. Again, B means S1, 1, S0. Similarly, it is done for the rest of the state. So, in this way, it is to be replaced or renamed. And once it is done, what we have to do? We have to prepare the state diagram from that modified state table. So, number of states are only row S1 and draw three circles. Row S1, S2. They are drawn with blue color. Then what is to be done? Just starting with S0, observe the input and write the next state. S0, if the present state is 0, 0, next state is S1. So starting with S0, the present state is 0, 0, next state is S1. It will S1. Then under input 0, 1, again the next state is S1. So 0, 1, S1 and 0. Under input 1, 1 again it is 1. So it is S1. Output is 1 and then 1, 0. It is the same 0. Then S1. So starting with this S1 condition or S1 state, if the present state input is 0, 0, next state is S0. So it will go to the S0. So here arrow. If the input is 0, 1, the next state is the same state in output is 0. If input is 1, 1, again the next state is the same state 1 here. And the last, when the input is 1, 0, when the input is 1, 0, next state S2. Similarly, it is done for yes. For input 0, 0, the next state is S1. So S2, S1 and output is 0. Again, for input 0, 1, next state is S0. So S0, 0, 1 and the output is 0. Then here error is there. It should be, no, it is S1. It should be. Then here after the input 1, 0, that is S1. 1, 0, that is S1 and output is 0. So in this way the state diagram is prepared used state table. In the starting state table there were 5 state, and after finding the equivalent state and eliminating those equivalent state, there are only 3 state. So to implement the state machine with 5 state requires 3 state variable, while implement a machine with 3 state requires only 2 state variable. So one of the state variable get reduced. So the resultant state diagram gets simplified. If you observe the first one and this one, the first is very appears to be very complex, while very simple and able to implement such state machine. So thank you very much.